Welcome to our poster. We are Group 6 from Ritsumeikan University, College and Department of Pharmaceutical Sciences. Today, we're here to discuss about the academic efficiency in Ritsumeikan BKC, Byakukusatsu campus. My name is Saiga Tanaka, and I would like to start off with talking the background and introduction of our project. But before that, I would like to ask you guys a quick question here. Who prefers to study in the university instead of their house? Please raise your hand in front of your videos. Legitimately, raise your hand in your videos. I want some Oh, right. This was a video. Sorry, guys. Oh, I totally forgot about it. Okay, never mind. That's why I didn't see your guys' reaction. When you think about it, it is obvious, right? Because the academic environment or the university itself is supposed to suit for academic purposes. And this is actually promised by several laws, such as the law decided by the Ministry of Education. But when you look specifically into these laws, you notice the fact that these values or the rule set have certain range within it. And several experiments have shown the fact that this range could cause certain effect to your efficiency in studying. An example of this would be ceiling height and background noise. Ceiling height actually have a range from 2.1 meter to 2.7 meter. And background noise is set at the maximum is only set at 55 decibels. But research showed that the difference, even within the range of the law, has certain effect to your concentration levels. In addition to this, there are several aspects that's not considered within the law. This is because the law only sets up the fundamental minimum for what academic architecture is supposed to have. An example of this is about green area. It's shown in several researches that green area actually have a certain effect to your cognitive reaction. And thus, considering these two factors, although in the law differences create a certain difference in study environment and efficiency, right? So understanding this fact, we actually focused on what about Ritsumeikan University campus, which we picked up most frequently used three facilities, which were Link Square, Union Square, and Co-Learning House. It was decided upon a survey done to 47 students of Ritsumeikan BKC, and all of these three facilities had the majority of the respondents answering that they use it frequently. So what we are looking into is within borders, not beyond borders, right? So our aim here in our project is to examine three environmental factors, ceiling height, background noise, and green area, and three frequently used facilities. And we would like to determine whether or not BKC is actually an academic friendly environment or not. The overall outline for our project is, firstly, we start off with method, results, evaluation, conclusion, and discussion. So first I would like to hand over to method, where Fumio Watsui would talk deeply about it.
I will talk about experiment outline. As overall flow, after determining the factors, we measure that, then compare to the desired value from reference. After that, we show the achievement rate. And finally, we evaluate. The detailed number of desired value will be described in the results. As environmental factors, we defined green area, background noise, and ceiling height. It is known that small changes in three factors affect academic efficiency. Therefore, I will explain each method based on these experiments. In the measurement of green area, first take 360-degree pictures of each facilities. Then cut out green area in picture and find the number of pixels. After that, find the ratio of green by dividing by the number of pixels in the entire pictures. With the entire pictures as 100%, the achievement ratio of green area is calculated. Using this, it was evaluated. In case of background noise, we measure the volume as the height that we usually study. After that, we compared the desired value and calculated the achievement rate so that it decreased as away from desired value. Using this, it was evaluated. Finally, the ceiling height. We measure the height of ceiling at each location. After that, we compared the desired value and calculated the achievement rate so that it decreases as away from desired value. Next speaker is Ryusei. He tells about the detailed desired value and the research results.
I will talk about results. In this experiment, a goal was set for each stress factor. The target was 100%, and the value of each stress factor was expressed as a percentage. The target of each stress factor was set to 100% for the green area, 35 decibel for the background noise, and 2.7 meter for the setting height. Similarly, the lower limit was set to 0% for the green area, 65 decibel for the background noise, and 0 meter for the setting height. Okay, please look at this table 1. This table shows the average of raw data obtained by measuring each stress factor at the facilities on the Ritsumeikan University BKC campus. The results obtained in table 1 were converted into percentage based on the above mentioned target values and lower limit values. Figures 1, 2, and 3 shows the achievement rates shown in this way using radar for each facility. Look at this figure 1. In Union Square, the green area was 3.5%, background noise was 18.7%, and setting height was 93%. Look at this figure 2. In Link Square, the green area was 6.4%, background noise was 43.3%, and setting height was 100%. Next, look at this figure 3. In Cloning House 1, the green area was 1%, background noise was 95.2%, and setting height was 100%. For background noise, the value indicated by this becomes a negative value, so please understand that it has been changed to a positive value for conveniences. Okay, next presenter is
Environment of Ritsumeikan University BKC campus was evaluated based on the calculated data. Table 1 shows that the value of the Link Square and Union Square factors were very similar. The green area and background noise were worse than the reference values. On the other hand, regarding the Cloning House 1, the ceiling height was 100% and the background noise was 95.23%, which was very close to the reference values. However, the green area showed a very low values of 0.99%. From the above results, it is not necessary to improve the ceiling height among the 3 environmental effects. However, the green area of all the measured facilities were small. A small amount of green area leads to a decrease in cognitive reaction. This leads to lack of understanding of classes and failure of the experiment. Next, the average value of the measured data was calculated and a comprehensive evaluation was performed for each facility. The summarized data are shown in Figure 4. From Figure 4, it can be seen the co-learning house 1 is the most suitable facility for the learning environment among the 3 facilities. Background noise was the decisive factors. The Union Square and Ring Square were very prominent in the student voice.
Thank you, Ayana. I would like to talk about conclusion and significance of this experiment. In this experiment, we consider the factors that cause the reduced efficiency in BKC. As a result, we found that there were few problems with the ceiling height. However, there were problems about background noise and green area. In other words, I don't think there's not problem with the structure, but there's a problem with the operations. We believe that the university needs to be reviewed the results in light of this study. However, in fact, there are still a number of problems with this study. For example, the sound level is to be lower than normal due to the coronavirus incident now. Another thing we didn't consider this time was the room temperature. This could not be considered because of the great influence of personal difference. However, it could have a huge impact on efficiency. A follow-up study is needed on these matters. That concludes the presentation of Group 6. Thank you for listening.